Hello class, welcome to this lesson on 7.3, trigonometric functions and real numbers. So we're going to split this section in this lesson into two parts. So we're going to be talking about part one today. And the goals for the lesson in general are to use the unit circle to evaluate the trig functions for any angle, and to prove and use the Pythagorean identity to find sine and cosine for any angle. So for this part, we are simply just focusing on using the unit circle to evaluate trig functions of any angle. Okay. Next part, we'll talk about proving and using the Pythagorean identity. All right, so the vocab includes the reference angle, reference triangle, terminal point, terminal side, and the unit circle. So some of this is review from the last lesson, so I wanted to include it here because we will be using these vocab terms. All right, so let's talk about the unit circle. So the essential question is, how is the unit circle related to trigonometric functions? And hopefully in this lesson you're able to find the relationship between those two. So a unit circle is simply a circle with a center at the origin and a radius of 1. Okay, so we're going to go ahead and show you that diagram here. So this is the diagram of the unit circle. All right, notice that each of the coordinates here at the edges is a coordinate of 1, right? -1 in the x direction because it's on the negative side, and then -1 on the y because it's on the bottom. But each of them have a radius of, this entire thing has a radius of 1. All right, very simple, but it's very powerful because it's a very powerful tool for trig functions. We'll talk about that. All right, so first off, an angle in standard position can be drawn on the unit circle, okay? So we're going to show you how to actually do this. You can always draw a triangle from the unit circle when given an angle in standard position. So let's show you how that looks like on the unit circle, okay? So we have our unit circle. We have an angle drawn in standard position, okay? So we have our initial side, which is the x-axis, right? We have the terminal side, right? And the angle that we're wanting to draw here is 60 degrees. So that's known as our reference angle in this case, which is the exact same thing as the angle in standard position, the angle measure, right? In this case, it doesn't really matter. It's still going to be the same angle, 60 degrees. All right, if we're talking about the positive angle measure, that is. But in any case, we're looking at a 60-degree angle. Notice that this 60-degree angle can be broken up into two pieces, right? We have the x side of that terminal side, and we have the y component of that terminal side. Notice also that the terminal side has a length of 1. That's because this is a unit circle, and this is a radius. So notice that I can take any angle, any terminal side, and I can break it up into these two components, and I can make a right triangle out of it. Notice that I can take any angle and make a right triangle out of it like this. This triangle is called a reference triangle, which is drawn by, you basically draw it by drawing a line straight from the terminal point. The terminal point is that ending point, right, on the terminal side, the very last part of the terminal side, which is in this case on the unit circle. You take a line from that terminal side, draw a line straight down or up, depending on where you're at. So you take that line and draw a line straight to the nearest x-axis, and it has to form a 90-degree angle like this. And then you extend you draw the other leg of the triangle, and that will be your x side. Okay, so this is how you can draw a reference triangle. All right, so we're going to talk about finding the coordinates of this in a little bit. But let me show you another example. Let's say we have an angle with a numerical measure of 210 degrees. That's positive 210 degrees, which means counterclockwise, so going against the clock. So in order to draw that, notice that 210 degrees goes all the way in quadrant 1, 2, 3. This is quadrant 3, right? So because it's quadrant 3, this triangle is going to be drawn in quadrant 3. So my terminal side is in quadrant 3. I have a terminal point on the unit circle. We call it xy. We don't know what the coordinates are yet. And I know that the reference angle is 30 degrees. How do I know that? Well, because I know that half of a circle is 180 degrees, right? And then I got to go an extra 30 degrees to get to 210 degrees. So I basically took 210 minus 180, and that gave me 30 degrees. So I knew that the reference angle was 30. The reference angle is very important. You're going to be using this when you figure out trig functions, ratios, okay? That reference angle, you need to know how to find it. So if you forget how to find it, refer back to lesson 7.2. All right, so we have our terminal side, and then from that terminal point, we draw a straight line that is at a 90-degree angle to the nearest x-axis, and that's my y side. And then we draw the other leg of the triangle, and that's my x side. All right, so now that we went over a couple of examples of how to draw the reference triangle on the unit circle, we're going to actually talk about how to find the coordinates of a point on the unit circle. Okay, so let's look at our first example. So an angle theta has a measure of 60 degrees and a terminal side that crosses the unit circle. What are the coordinates x, y on that unit circle? So we basically this is the same diagram that we used previously, right? We have an angle that is 60 degrees positive, so counterclockwise, which means that the reference angle is also 60. We draw a reference triangle. Notice that this bottom side is x. This right leg, this here is y. That's because, you know, when you're doing coordinates, that's how you travel along xy, right? You travel x direction and then y direction, and that gets you to your point xy, right? So if that coordinate were 1, 2, then you would have to travel 1 from the origin and then up 2, right, from that point. Okay, so that's my xy. Notice that the terminal side has a length of 1 because this is a unit circle. And circle has a radius of 1. All right, so then we're going to take that reference triangle and we're going to focus on that triangle. Notice that that triangle is a 30, 60, 90 triangle. That's because we know that this angle right here is 60 degrees. So this right here is 60 degrees, which means that this has to be a 30 degree angle. So it's a 30, 60, 90 triangle. So it's one of those special triangles that we talked about in the previous lesson, right? In 7.2. So what we're going to do is we're going to draw the 30, 60, 90 reference, right? Our triangle as a reference. So remember that the 30 degree side has the square root of 3, 60 degree side has the a, and then the hypotenuse has 2a. So we notice that the 2a is equal to 1, right? So therefore, we can solve for a. In this case, 2a equals 1, so that means a has to be a half. All right, so now that we got a as a half, let's look at here. Well, we know that the red, x is equal to a. So if x is equal to a, well, that means x is a half because a is a half. We just found it earlier. We also know that y is equal to a square root of 3. And we can plug in a as a half into that. And if we do that, we get square root of 3 over 2 for my y. So therefore, my xy coordinate for that unit circle is x, which is a half, and y, which is square root of 3 over 2. So that's my x and y coordinate for that particular angle on the unit circle. Now, notice that the x and y are positive because we're in quadrant 1. Okay, so since we're in quadrant 1, we know that x and y has to be positive here. Okay, so that's very important. If you're in quadrant 2, then you're going to have a different sign, right, for x and y. All right. So now one more thing that I wanted to mention is the relationship between the unit circle or the coordinates on the unit circle and the trig functions. So notice that if we use SOHCAHTOA, remember SOHCAHTOA means sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA, tangent is opposite over adjacent. So if we're interested in doing the cosine of 60, then we're looking at C-A-H, so COTOA. So in this case, the adjacent to 60 degrees, and we're focusing on the 60 degrees here. Let's see. The adjacent to 60 degrees would be, in this case, x, right? And then the hypotenuse would be 1. So therefore, cosine of 60 is equal to x over 1, adjacent over hypotenuse, which is x. So that means that the x coordinate is equal to the cosine of the angle for the angle that you're interested in. This is always going to be the case for the unit circle. And then sine of 60 is opposite is the y, over hypotenuse, which is 1. So sine of 60 equals opposite over hypotenuse, y divided by 1, which is just y. So that means that the y coordinate is always equal to the sine of the angle on the unit circle. Very important. And then using, therefore, the x is a half, y is a square root of 3 over 2, which is what we found out earlier. And then to find the tangent, right? To find the tangent, remember, tangent is opposite over adjacent, TOA, right? So opposite is y, adjacent is x. And therefore, to find the tangent, we simply do y divided by x. Now, if we wanted to do secant, remember secant is the flip of the cosine, then we would just have to flip x over 1 and make it 1 over x. If we wanted to find cosecant, we would have to flip y over 1 and call it 1 over y. If we wanted to find cotangent, then we would have to flip the square root of 3 over 1 or make it, instead of y over x, we're going to do x over y and then get cotangent. All right, so a couple of little side notes there. So let's look at another example, example 2. An angle theta has a measure of 210 degrees and a terminal side that crosses the unit circle. What are the coordinates x, y on that unit circle? All right. Okay. So if we want to find the coordinates x, y on the unit circle. So here's our unit circle. Again, same diagram as it was earlier, because we did the 60 degree and then we did the 210 degrees. So again, same that kind of diagram. Our reference angle is 30 degrees. We're trying to find the coordinates of the terminal point. All right, so what we're going to do is we're going to focus on this triangle here. All right, so looking at this triangle, we know that it's a 30, 60, 90 triangle as well, because our angle of interest here is 30, so this has to be 60 down here. All right, so remember, we're focusing on the reference angle. The reference angle here is the 30 degrees. And in fact, I'll go ahead and bold that. That's the angle that we're interested in. And I'll do that over here as well. Okay, so now we're not interested in the 60. It's just telling us that it's a 30, 60, 90 triangle. So basically, we're going to redraw the triangle. Remember, the 30 degree side has the square root of 3. The 60 degree side has just the a. And then the hypotenuse has the 2a. All right, so if we did the cosine of 30 degrees, that's going to be adjacent, which is x, over hypotenuse, which is 1, which again gives us the x coordinate, which is what I was saying earlier, that the cosine is the x coordinate. In this case, the sine of 30 degrees, opposite over hypotenuse, is going to be y over 1, which is y. And then similarly, to find the tangent, you do y divided by x, and then to get the tangent. And then you're going to have to do some math here. You're going to have to use KCF in order to divide two fractions. And then to get from here to this side, you're going to have to multiply by, you're going to have to rationalize the denominator by multiplying square root of 3 on top and bottom. Okay, so that's how you get sine, cosine, and tangent. Again, if you wanted to get secant of 30, you would have to do 1 over x. You would have to flip x and 1. To get cosecant of 30, you would have to do 1 over y. Let me get rid of that. To do cotangent, I'll put it right here, you would have to do x over y. So you'd have to take x divided by y, which means you would have to do square root of 3 over 2 divided by a half. And then you'd have to flip. So basically these 2's cancel, leaving you with square root of 3. And that would be the cotangent of 30. All right, so that's how you find the trig functions by making the reference triangle based off of the coordinates, right? Based off of the angle that you're interested in. So then what is x and y? Well, we just found it, right? We said that the x was cosine of 30. But let's go ahead and see how we actually found it, right? How did we find x and y? Again, the hypotenuse is equal to 1. So that means that 2a is equal to 1, which means that a is a half. So you're going to take that a and you're going to plug it in for x, because we know x is equal to a square root of 3. So therefore we plug in a half into a right here, and then 1/2 times square root of 3 is just going to be square root of 3 over 2. And then lastly, we know that a has to equal y, and we know a is a half, so that means y is a half. All right, so that is my x and y. However, to finalize the coordinates of the unit circle, we need to figure out, okay, well, we know it's in quadrant 3, right? Because it's in quadrant 3, this means that the x is negative and the y is negative, okay? If you think about when you're traveling on quadrant 3, that means you have to go left, and then you have to go down, right? Which means a negative x and negative y. So therefore, our coordinates are both negative for our final answer. So this is very important. Keep in mind the quadrant that you're in, so you can finalize your answer according to the sign based off of the quadrant. All right, so let's look at, let's basically summarize what we talked about. So to find on the unit circle, the x value is equivalent to the cosine of the angle of interest. So x is equal to cosine of theta. On the unit circle, the y value is equivalent to the sine of theta. On the unit circle, the ratio of y to x is equivalent to the tangent. Okay. And then we'll go ahead and summarize those other ones, the other trig functions. So we know that 1 over x is secant. We know that 1 over y, you basically just have to flip y, which is 1 over y, is the cosecant of theta. And x over y, if you flip y over x, is going to be the cotangent of theta. So those are our 6 trig functions. Even though you'll have practices on the 6 trig functions, I'll only be quizzing you on like the first 3 trig functions, sine, cosine, and tangent. Those are the ones that I really want to focus on as far as quiz is concerned. But you will on the practice, you will have all 6. All right. So that's that. So now let's talk about the steps to find sine, cosine, and tangent on the unit circle. So if you want to find, the cosine of any angle that's a special angle, you have to follow these steps. First step, identify a reference angle and the quadrant in which the terminal point lies. So figure out which quadrant you're in based off of the angle that you're looking at. Draw a quick sketch using the unit circle, the angle, and the reference triangle. So first, you need to find those things. It helps if you have a picture in mind. Use these special right triangles to find the x and y coordinates as well as the ratio of y over x. So use your special triangle knowledge to help you find those coordinates, okay? Remember that x is cosine, y is sine, and then tangent is y divided by x. All right, determine the signs of the x and y coordinates. So if the terminal point is in quadrant 1, remember if you're in quadrant 1, that means that both x and y are positive. If you're in quadrant 2, that means you have x is negative, y is positive. If you're in quadrant 3, that means that x is negative, y is negative. Quadrant 4, x is positive, y is negative. Okay, so just think about the traditional quadrants for the unit circle. All right, so we're going to actually talk about filling in the unit circle. This is going to help us with these steps, okay? So let's talk about the unit circle. This is going to be your go-to for a bunch of stuff. So if I ask you like what an angle is, the sine of an angle, you can use this to help you, all right? I would highly suggest, dedicating this to memory, because in the future, if you ever go into pre-calc or maybe another lesson in this course, you're going to need to kind of know what those are. All right, so let's talk about it. So there's a bunch of different angles here. What are my special angles? Okay. Well, first off, you have 0 degrees. You have 30 degrees. Think of 30, 60, 90. You have 45 degrees. Think of 45, 45, 90. You have 60 degrees. And you have 90 degrees. Okay. All right. So then what are my other angles? Well, I know that this has to be 180 degrees. Okay. Remember that half circle is 180. And if I go back to here, if I go to one full circle, that's 360. That'd be one full circle. All right. Remember that 180 degrees is the same thing as pi radians. So on the dashed line, that's our radians. Okay. 0 degrees is just 0 radians. I'm not going to write rads anymore. I'm just going to write what it is. Okay. But just so you know, for the first one, it's in rads. For 30 degrees, how do we convert 30 degrees to radians? Well, remember that 30 degrees is the same thing as pi over 6. Remember that. So if you want to convert it, and I'll show you that real quick, just once. Degrees goes on the bottom, so it has to be 180. Pi has to go on top. So if I reduce this, this is going to be 1 over 6. So that's pi over 6. Okay? So this is going to be pi over 6. All right, I'm not going to convert the other ones. I'm just going to go straight forward, okay? So 45 degrees, using the same conversion, it's going to be pi over 4. For 60 degrees, using the same conversion, it's going to be pi over 3. For 90 degrees, it's going to be pi over 2. All right, so what are these other angles? Well, I know that the reference angle for this is 30 degrees, right? Because on the other side is 30 degrees, so this has to be 30 degrees as well. They're symmetric. So therefore, I know that this has to be 150. 180, take away the 30. The next one is 180, take away the 60. So that's going to be 120. Oops, not 60, sorry. Take away 45. I went ahead of myself. This one's going to be 180, take away 60. This one's going to be 180, take away 45. So it's going to be 135. So that's how I find those angles. All right, so how do I convert 120 to radians? Same deal. You're going to multiply by pi, divide by 180. So in that case, let's see here. So we have pi over 3. So this is going to be 2 pi over 3. 135. This is going to be 3 pi over 4. 150 degrees. Yeah, so this is going to be 5 pi over 6. And then we got pi. So those are our radian measures. Now let's go ahead. I'm going to fill in the rest of the circle real quick. All right, so I went ahead and filled in the angles for the rest of the circle just to save us a little bit of time. So again, try practicing. I would suggest try practicing, finding all of these angles and then converting them to radians. Okay, so it's very good practice to do that for the unit circle. Now, what we're going to do is we're going to find the coordinates of each of these coordinates. Now, some of these are very easy to do, so let's do the easy ones first. This first one, the x coordinate is 1 because we know that the unit circle has a radius of 1. And then therefore y has to be 0. So that coordinate is very easy, 1, 0. For this coordinate over here is 0, 1. That one's pretty easy to find. The one on the left side is -1, 0. And then we have on the bottom here 0, -1. Again, those are pretty easy to find. So what this is saying, remember that the x coordinate is the cosine, the y coordinate is the sine. So this is my cosine, this is my sine. Now that we know that cosine is the x coordinate, sine is the y coordinate, we can use that to our advantage, right? So that means that the cosine of 0 degrees is 1, the sine of 0 degrees is 0. All right, now let's go ahead and do 30 degrees, okay? So this next one. So how do I go about doing 30 degrees for this one? Okay, so what I'm going to do is I'm going to draw a reference triangle. I'll draw it over here real quick. Just a quick little triangle. So that's my 30 degrees on that unit circle. This is the coordinates x, y, right? So we're going to draw a line straight down to the x-axis. This is my y, this is my x. Now I know that the radius of that unit circle is 1. So that triangle has a hypotenuse of 1. This is a 30, 60, 90 triangle, folks. So that means we can use this to find, you can use the special triangles. Okay, so we know that it's a special triangle, 30, 60, 90. The 30-degree side has the square root of 3. The 60-degree side has just the a, and then this is 1, right? So I know that just like it was before, oh, I'm sorry, this is 2a. 2a for the hypotenuse. So just like before, I know that 2a is 1, so a has to be a half. So therefore, this is a half, and this is square root of 3 over 2. Very quick. You can do it quickly if you're pretty good with your special right triangles. So I know that x is square root of 3 over 2, and y is a half. So those are my coordinates, and they're both going to be positive. Okay, so I know that x here is square root of 3 over 2 and a half. Okay, and then we're gonna do one more just to give you an idea of how to do this. Okay, so I'm gonna do one more, and I'm gonna do it in quadrant 2. So let's say we wanted to do the sine of 3 pi over 4, right? Let's say we wanted to do 3 pi over 4 or 135 degrees. So what are the coordinates there? Okay, so let's say we want sine of 135 degrees, cosine of 135 degrees. Well, I know that the sine is the y coordinate on the unit circle. I know that cosine is the x coordinate. So I know that 135 degrees, excuse me for that. I know that 135 degrees is in quadrant 2, right? And I know that the reference angle is 45 degrees. Take 180 minus 135. Therefore, I can draw my right triangle like that. This is x, this is y, this is 1. This is a 45, 45, 90 triangle. So therefore, I can draw a 45, 45, 90 triangle. That's from the previous lesson. Remember that it was a square root of 2. So I know that 1 is equal to a square root of 2. So a equals 1 divided by square root of 2. And there's my a. And then I'm going to go ahead and rationalize by multiplying by square root of 2 on top and bottom. That will give me square root of 2 over 2. So I know that x is equal to, these are both equal to a, right? X is equal to a, and so is y. So that means they're both equal to square root of 2 over 2. So the cosine, so we know that the coordinates are square root of 2 over 2 and square root of 2 over 2. However, what are the signs? Well, we know that we're in quadrant 3 right here, right? So since we're in quadrant 3, that means x has to be negative, or I'm sorry, quadrant 2. I said quadrant 3. This is quadrant 2. So x has to be negative, y has to be positive. So therefore, sine of 135 degrees is the y coordinate, and y is positive. Cosine of 135 degrees, that's the x coordinate, and x is negative, so it's going to be negative square root of 2 over 2. All right, so that's my cosine and my sine. And then I could do tangent by dividing those two. All right, so I'm going to go ahead and list those out. So I know these now are going to be negative square root of 2 over 2 for the x, square root of 2 over 2 for the y. And that's how you find any coordinate on the unit circle for those special angles. I'm going to go ahead and pause. I'm going to go ahead and quickly, using video editing, just go straight to listing all the coordinates for you. Okay, I'll be back in a sec. All right, guys. So I went ahead and fill in the other coordinates. Again, notice that the coordinates are all the same, right? So you have the same numbers for the coordinates. You got square root of 3 over 2, you got a half, you got 1, 0, a square root of 2 over 2. So those are the only numbers that you're going to be using for these special angles. And if I wanted to find any of these angles, they're just negative or positive versions of each other. So I want you to go ahead and try practicing on the unit circle by drawing the reference triangles, using your special right triangles to help you find the coordinates, reviewing radians, and then you should be fine for finding cosine, sine of any or tangent of any special right triangle of any special angle using this unit circle. All right, take care, guys. I hope you have a great day. Stay safe out there, and I'll see you in the next one.